Hi, William Bastas, Blacksmith School, and I'm in the midst of making a pair of tongs. Every episode, whether you started from watching from the beginning or midway or at the end, you'll probably find something of use in the approach and in the information. So today what I'd like to do is finish my tongs. I'm going to show you the steps that I go through. We're dealing with some wasps here and there, so if I scream, you'll know why. But I punched the hole and I drifted it with 3/8 drift. I showed everybody how to forge a 3/8 drift, or just forge a drift in general. It's like the entrance taper, the refinement area, and exit taper. I used a tool that I made, and let's go over here to the anvil. I didn't really describe this tool. It's just a piece of pipe that I put a collar on. I welded the collar underneath, and I welded a little piece of 3/8 thick that I cut with a hole saw. It was my drop from using a hole saw through thick plate, and then I enlarged that hole to slightly larger than 3/8, so that when I drifted, I could drift my tongs. My tongs over here again. I could drift my tongs, and it wouldn't damage the amount that it spreads this way and the amount that it spreads this way. If I drifted them here, then it's going to bend it because it's going to sit on that both ways. By the time I get through drifting it, it's going to kick that over. So by using this tool, and I make sure that it's nice and flat, I drifted this, and then since this is hollow, then it went through and it fell into the quench tank. So came up with this tool just because there's just been a lot of times when I've run into that situation. Now, I drift that, but it's not perfectly round, and it's close enough. It's probably about a 64th off. 3/8 is the size of the rivet that I'm going to use. 3/8 won't quite go in there because when the steel shrinks, it shrinks about 1/8 of an inch per foot. I'll demonstrate that in a future video. I take a 1 foot long bar and I'll measure it. It's right on the money, 12 inches. And I put it in the forge, and it grows at least 1/8 of an inch, sometimes like a little bit shy of 3/16, but you can guarantee 1/8. So 1/8 per foot is quite a bit. So 1/8 per foot won't allow you to put a heated piece of steel in that constrained dimension, and vice versa. When it shrinks, if this started off as 3/8, it's not going to be 3/8 when you're done with it. Besides, there's probably a ding or two of hammer blows on that. But that's interesting. That's how you set pulleys on shafts, and there's a lot to that concept of the steel shrinking around another piece of steel, and it's a very shrink fit. It's a very sturdy joinery connection. So we drifted this. It shrunk a little bit, but I like the hole not to be a drifted hole, because the drifted hole can still be, even though it had the refinement area of the taper drift, it could still be a little wonky. So when I drill this, it'll clean up any wonkiness. It'll give me a nicer pivot. Once I've got that drilled to 3/8, and by the way, 3/8 is a nominal size for rivets. Rivets are sized slightly smaller than 3/8. So when I drill a 3/8 hole, the 3/8 rivet will go through the hole. So you can see on this gauge that this is 3/8, and this is 3/8, and the hole, the rivet will fit through the 3/8. So you don't have to drill it larger than 3/8. That's already been calculated. So what I need to do is I'm going to put my rivets together as a dry, or my tongs together as a dry run, and I use a 3/8 bolt, stainless bolt, but it doesn't matter. And when this fits in, I'll be able to put the tongs together, and I'll see how well they fit. I can tell you right now what I'm going to need to do is I'm going to have to relieve a certain area right here. I'm gonna grind that part off so it makes a V right here. And if you do that, then you'll get about 15 degrees more opening on your tongs. So there's no sense in having a pair of pickup tongs that doesn't open 90 degrees. I want them to open a full 90 degrees. So I'm gonna grind that portion right there. So that'll make that a V instead of it having that angle. It'll just knock that right off. So I consider this like the machining process or the cold work, just the refinement. You could put a pair of tongs together right after you forge it, and they'll fit, but they just won't have these like subtleties of opening up that extra 15 degrees. Now, another thing I could have done is when I set the shoulder, and I demonstrated this 2 videos ago, when I set the shoulder at 45 degrees, I can alternate 45 here and 45 here and 45 here, back and forth, so that when I come down to this dimension, I not only have my angle here, but I also have the angle here. But frankly, I like the way it looks when it's cut with a grinder, because it's a tighter fit and it looks more purposeful. So that's where I'm going with it. Point out some of the tools that I've used in the forging of these tongs. You saw this, the stanchion for the drifting. You saw the cut plate, so that when I split out the jaws and I slit the improved super groove, then I didn't damage my chisel. So I explained that the concept of that canoe-shaped chisel, I showed how to sharpen a punch, and that punch remained sharp, and I explained why I use H13. Also explained that idea, if you have polished tools, then you'll wind up with a really polished surface. So I'll be using this tool in a bit to set the hands of the monkey hand. Right in here I'll be swaging this, and I forged this to 5/8, and but I realized that I needed 7/8, so it's kind of fun if you make your own tools. You can modify your tools. I don't recommend modifying a lot of your tools. If you need a tool, make the tool. Although I made this as a demonstration, and it was a 5/8 swage, but I use 7/8 more than I use 5/8, so I modified the tool. And if you make your own rivets, it's handy to have a bolster. So I'm going to demonstrate how to make nails and rivets in a future episode. But this bolster has graduated holes by 1/16, and it'll allow you to shoulder, nick, break, and upset the head. So the bolster will also act as a heading tool. This is a very simple way of making a bolster, just perhaps a 3/4 inch plate, and drift your, or drill your holes. Now, radius on one side, so this is fully radiused, and I would recommend this bolster has been radiused on both sides, but I'd recommend one side to be radius and the other side to be not radius. So this is the not radius side. So if you want a crisper edge on a shoulder, for instance, if you're using this to clean up a tenon, then you don't have that radius. So every tool should have multiple applications, even the same tool on the opposite side. So we'll talk more about that bolster in a later video. So here's our sequence where we are, and we're pretty close. And you might think, well, you're just about 5 minutes away from finishing the tongs. Well, I'm probably an hour away. So we started off with the number 6 rebar. We drew out the rein with 7 inches, drew it to 11. We started forging the offset, the first offset. Remember the bulb, this goes to 3/4 of an inch, this is 3/8, so that goes half the dimension. Then it gets drawn out to 3/8 by about 3/16. This is it's about right, 3/8 to about 3/16. Then we forge the rein. That rein goes, it's the journeyman test, where it's decipherable taper, so there shouldn't be a hollow in here. So it's a straight line from there to there, and then conversely it's a straight line from here to here. So it's a opposing taper, and it's a very handy shape on tongs, and I like it because aesthetically it's pleasing. It also puts every ounce of metal where it needs to be. There's no wasted steel. So it's not only cost effective, it's also weight. If I have 2 pair of tongs and one weighs more, but they do the same job, I'm probably gonna choose even subconsciously, I'll choose the pair of tongs, first of all, that fit best, but the ones that are lighter. So here we are after the reins have been drawn, the hole has been punched and drifted, the super groove has been fullered and slit, and the ends have been split. They should be, this is a little thick, but the fuller that I'm going to use to swage this is half of an inch, and so that's about 3/16. It's a little bit thick on 3/16, but it needs to be heated a couple more times. That's a little thick And I look at that like 3/16 plus. Instead of having to figure out, it's like, is it 6:30? Is it 7:30 seconds? Is it 15/64? So I just say, so that it allows my mind to do other things, I just say that's like a 3/16 plus. So I know that I've got some extra material in there, but 3/16 and 3/16 plus half of an inch gives me 7/8. And I swaged, I fullered my swage to 7/8 of an inch. And so you'll see how I use that. Now I've chosen a 3/8 bit. And I also, in future episodes, I want to show you how to sharpen a bit, and I'll actually destroy a drill bit and then I'll bring it back to life, just because in your shop, when you may not have time to replace a broken bit or a dull bit, and it'll save you so much time. And it's just a fun thing to practice sharpening bits, and you can do it with a grinder. You can do it with anything that spins. You can do it with an angle grinder, a chop saw, a sanding machine, anything that spins and creates a spark, you can sharpen that bit with. So it's not high tech, and I want to take the mystique out of sharpening your own drill bit. So here we are. When last time I used this tool that I made, and I explained that Wendell Broussard developed the tool, but really I made some modifications on it, because the initial tool, it has a lever that it's not this complicated. All it is this gas saver. It's got a lever that comes out with a little notch in it, and then you just set your torch on that. This is your pilot, so when you raise your torch off of that notch and you sweep it across your pilot, then it lights your torch. And Wendell Broussard's idea was like, put this out here and then have a rod that lifts that lever and move your pilot over to that lever. So you'll see treadle torches that are designed like that. They have a lever that comes down, the pilot is over here, and a rod that kicks up on that lever. So when you step on this treadle, it lifts the rod. But I found that using the treadle torch, and I use the torch frequently for forge welding, and that I'm not torch welding, I'm using the heat source to heat the steel to get, if any flux or any hot steel drips on that pilot, then it destroys the pilot. And that pilot's not cheap. This one's designed for propane. They also are designed for. So what I do is I sweep that across. So that when I heat here, and of course I'll have a shield on it, but when I heat here, then I don't destroy my pilot if anything drips. Now, you know, it may come to a point in time where I just need to put a little piece of sheet metal here to protect the quick release on that. But anyway, so that's the reason why I made it like this. I wanted one to be angled, I also wanted to be straight up, but I found that straight up was kind of dangerous as far as like anybody walking by. So by having it angled, then that allows that torch to angle down. And I'll turn the torch on later, but I just wanted to explain to you why I made it like I did. Of course, you can see that if I need to, I can set this hook, and in that way the torch always stays on, because the lever is now released and the fuel's flowing through the hoses. So if I'm doing a lot of work with just a torch, I can either turn it off here, or I can come back here and release that lever, so that turns it off. I've got a little rubber band or inner tube that I lined these pieces of angle iron with, so that it's a soft grip, and also it's got good friction and it keeps it from slipping. If you're going to do a lot of torch heating, you need to get a set of number 3 flip downs. These are about $12. They're AO, I guess American Optical, might be Phillips, but they don't last a long time. But if you take care of them, they're going to be really good. They're very handy when you're torch heating, and 3s are good for welding, forge welding, but not for, you know, gas welding, that kind of thing. But I keep my furnace flip downs right there, because if I need to, if I'm looking at the flame a lot, that puts out a lot of light. It's not as much light as welding. It depends on the fuel. Acetylene is going to be quite bright. Propane is not as bright. But if your eyes are like kind of adjusting after you look away, then you're looking at too much light. So it's not a bad idea to wear the number 3 flip downs when you're looking into a fire. Definitely when you're working with a coal forge. Coal forge requires that you can see what is being heated. When you're working with coke, you just Hail Mary, you just kind of put it in there and hope for the best. But with coal, you build it and you make an open fire, you make a tunnel or you make a cave, and it requires that you pay attention to your heat because you can instantly melt it, and there's so much bright light in there you'll damage your eyes. So there's a lot of things in blacksmithing just pay attention to, and you should be aware of that. I went to a flower making workshop once, and nobody had these flip downs, and nobody could hit their welds. They were all fire welds, and nobody could hit their welds because they couldn't see it. And I had an extra pair I gave to one of the students, and she was able to hit her welds. It was because you have to be able to see your heat. So it's really important to, again, you have the hearing protection, eye protection, breathing protection. All these kind of things are going to be important for safe longevity in the blacksmith shop. So what I want to do is I'm going to come over here to the drill press. My shop is kind of tight. It's 600 square foot. I'm using and overusing the space. Kind of have too much stuff in here, but it's what I feel comfortable working with. And so my drill press is kind of nestled in between a vise and a coal forge and a hydraulic press. But when I need to, I'll move things around in order to make things fit. But for now, I'll easily be able to ream these tongs. So I like a foot pedal on a switch. And there's the Ross bits. This is his drill press, and it's really my drill press. But I like a foot pedal, a hands-free, so that if I get wrapped up in the drill press, I can take my foot off of it. I just have to remember that my foot is on the switch. But a lot of things that I'm sharing with you out of like my own experience and sometimes my own injuries. But I was in a situation where I was hand holding a polished brass ball that needed to be reamed. I didn't think about chucking it or making a high molecular weight plastic jaws or anyway. So it got hung up, but the switch was on the other side, and so I'm fighting the motor, and the chuck is digging into my arm. So that's when I decided I'm always going to put foot switches on a drill press. And you can buy them $25, $30. It's if your switch goes out from the side, just wire in a foot switch. Now I'm going to grab my safety glasses. You know, safety glasses are important in the shop. They're like a seat belt. And if when you're driving your car nowadays, it almost feels like you're going to launch out the window if you don't have your seatbelt on. And that's the same way I want you to feel when you start working in the shop, is that there's something I'm missing here. And it's because when you put your safety glasses on, it's like, and sometimes gloves. I don't recommend gloves at the drill press. I recommend getting dirty. I have two friends that lost fingers at the drill press, and one fellow, he's got a great attitude about it, just makes joke about, you know, how he can't like eat M&Ms anymore, and how he can't scratch his butt. I mean, there's all kinds of things that he used those fingers for, but I prefer to hold on to my fingers. And so drill press is a very insidious tool that can really wrap you up. I really feel like a drill press should have a 3/4 horsepower motor. One starts getting kind of big, especially for the lighter work that we're doing in a blacksmith shop. But if you have a 1/2 horse or less, it's just going to spend a lot of time wasted at the drill press waiting for the drill to cut. So this is the size that I prefer. Now, when you're using your drill press, you may want to oil it occasionally right there on that chuck, and that will oil that chuck and make it so you just put a little oil here, and it'll make it so that your chuck grabs so much better with a little bit of oil. And that's where it needs to be, is right there in that, and it'll drain down into the bushings of the bearings. And what it'll allow you to do is actually have a better grip, because now you're not fighting friction. Now, notice what I did is I opened it and I closed it and I opened it again, just to make sure that those three jaws are centered. Now, use your chuck key with the handle up, because most people use the chuck key with the handle down, and then that's where it wears out. So sure, you can use it on the bottom, but the hidden bonus is the teeth on the top. So I always use the chuck key with the teeth on the top, and I'll chuck it up using all three holes. It'll give you a little bit better grip on that. Okay, so I like a slower speed on the drill press. So I put a 2-inch pulley on this. It had a shiv pulley that had like 7 different speeds, and I found myself using the lowest speed anyway. in metalwork, you need to slow that bit down because you don't need anything sudden. Now, since this splays out, we need to have, and I bought this from Alamo Ironworks about 22 years ago, and when they shut down the first time. It was a real interesting story some other time. But they sold all the whole plant, and then somebody got sued, and then they had to buy the equipment back. But this was one of the drill presses, cost me $5, needed a motor, but that's why it's kind of crusty, and that's also why it's got all of these. Now, this table will pivot, and it'll move over, but just make sure that you are not drilling through your table. So I always use a piece of wood, and a piece of wood also allows me to rock my work, to adjust my work. So I don't care about, you know, drilling holes into the piece of wood, but there's very little metal left on that table, but it's still a good drill press. So all I'm doing is reaming it, and that should give me a 3/8 hole. I'll have to check there because I already drifted it to 3/8, and I'm only reaming it now. I'm not using any lubricant on it because it's just taking off like a little edge here and there. So now don't let it hang up or climb on you. So I'm pushing down when I'm giving it that pressure, but right now both the pieces are reamed, and so now I'm going to go to the grinder station, and that's what I was saying is I want to knock that little corner off with the grinder, and I just find that it just looks so much cleaner. But I'm going to make sure that I've got the holes lined up, so now the bolt should fit in the reamed hole. And so these are going to be married for the very first time. And I'll secure this with a nut. And right now I'm not going to tighten it down. I'm just going to note where, so if I riveted it, I'd get this much movement. So if you look at it, this is level, that's 60 degrees. I get 60 degrees, but if I knock that corner off, I'll get 90 degrees. And that 15 degrees is priceless because you can't buy that when you're in the middle of a heat and your tongs won't open up wide enough. So you might as well make them so that they will now, all right? Things are kind of like one's on one side, one's on the other. We were talking about left-handed tongs and right-handed tongs. And these are going to be right-handed tongs, but they're really right-handed tongs if I didn't offset them, if I just bent them so that they came in by the time here. And that's kind of what they do, is they finally meet here. But I'll be offsetting my tongs here, and as an example, let's see. As you can see, I offset them here. So really, these are left or right-handed tongs. So if you didn't offset them, eventually the tongs reins need to meet here at the end. But if you hold on to them in the middle, they just feel odd to left-handers and they feel better to right-handers because of that offset. So that's really the only difference between left-handed tongs and right-handed tongs, is how they feel in the hand. So since I'm going to be offsetting them, they will be ambidextrous, thanks. All right, so the next thing I want to do is I can mark this as far as where it needs to be ground, but I already know. I'm just going to knock that corner off right there. So I'm going to work over on this station. Now, I don't like to grind inside my shop. I'm going to grind outside. My grind is going to go straight down into, dang it. But I don't like grinding in the shop because that's why I have my belt grinder out here. Both my belt grinders, my angle grindings, is so that all of the abrasive that in the powdered metal, it comes off here and it fertilizes the grass. Grass doesn't care, but just be aware that it's not a bad idea to keep your shop clean. The power hammers, I have 3 of them, and I'll illustrate why I built that power hammer. But the power hammers have oil on the rams, and any grinding is going to eventually find its way on the ram, and it's going to be damaging to the ram. So I don't want it to be part of my dirt. My dirt is organic in here. I want it to be clean dirt when I kick it around. So So I'm gonna grind. Now, I use this Ryobi because it's handy. It's not super powerful. My grinders of choice, they used to be the Milwaukee tools, but I had a Black & Decker 2750 for 20 years and I couldn't kill it. So now I just buy Black & Decker 2750s. They're called industrial. They're no longer Black & Decker. The Black & Decker turned to DeWalt. But if you can find an old Black & Decker 2750 that's in good shape, buy it, because man, those things, they are indestructible. For this demo, I want to illustrate with this Ryobi, and it's not a shabby tool either. We talked a little bit about this last time. So I'm going to use this foot vise just to hold on to it. And when anybody is in the area, dogs in the area, people are walking by, just make sure that you're not grinding at them. So we moved Dang It over a little bit so that we wouldn't get any complaints about our abuse of our dog. But so I want to show you the angle that I go in, and I need for it to be flat, and then it's going to create a ledge, and so I'm going to lift it up in order to grind off that ledge. So again, I'm going in, and I'm going to lift. So that's the end result of that grinding. It makes that area flat, and you got a nice clean shoulder, and then all of that will go together like more workmanlike. It'll be really pretty. So the grinding polish will disappear in the fire the first time I heat it. Okay, now I'm going to see if that gave me more than 60 degrees. I may still need a little touch up. So it actually closes more, and then let's see how much it opens. So I got my 90 degrees. Okay, and it just takes a second to knock that little corner off, and then it's worth it. Read my punched hole to 3/8, so it fits the 3/8 rivet. Relieve the pivot with the grinder, and I'm going to swage the ends. Always stay busy in the shop. There's no downtime in the shop. So while that's heating, I'm going to get this ready, then I'm going to put those in there, and then I'll get other tooling ready to go. Set these in. I'm going to sequence them so that it gives me time. If they were both heated at the same time, then I would have a situation where I'm going to get excessive grain growth. And the worst place to get grain growth on these tongs is at the split where they come out. If you're careful with that, they'll be tough and they'll bend. If you have excessive grain growth, they'll break off, and that's very disappointing. So I'm going to be real careful about sequencing my tongs. Now, like that. remember, the term I use is babysitting. That term will go nowhere in any other blacksmith shop, but it's just something that came out as like, yo, you need to babysit, and it became. So I'm babysitting my tongs at the forge, and so this one is ready to go, and I don't have to do all the work at once. Got started with that. Two irons in the fire, the heat will sequence. But what's important on a pair of tongs is not the dimension here to here or there to there. What's important is with the dimension from the pivot. So that needs to be the same, that dimension from the pivot to here, and that's why I developed that tong, or that tool. Everything is perpendicular, I'm working perpendicular. Solid contact, I don't want to hammer it anymore because it's going to thin it. I'm just hammering it to the point in time where it's going into that void and making contact with the bottom of that swage. So that's done. You can hear it when you're at the bottom of that tool. It goes thunk, thunk, and then it goes plink. And when you hear that higher pitch, you want to stop hitting. So now we're here, and they're getting closer, and the ends are shaped relative to the pivot, not to any other dimension. Okay, next step is I want to make sure that this is nice and flat. So you can do that at the anvil. Last time I showed you how to radius the edge of an anvil. What I can do is I can heat this eye, and at this point in time I'm going to be really careful about my heats. I'm going to heat the eye, and I can use a flatter to do that. So I can put the flatter here and I can drive it down. And I'll do one like that. I also want to show you on the fly press. Again, I'm heating there, there. There, there. After residual heat in this tong, it won't take very long to get hot. What's important is the flatness of the joint on the inside. And we talked about that when I was forging it. But now to confirm it, I'm going to use a flatter. So that's enough heat to flat it. And again, since this is wider, I want to keep that off of the anvil. And I'm going to put my flatter on it just like this. Measure where you're going to hit, and then give it a good wrap. So what that does is that makes sure that that is on the inside is nice and flat. I always say measure. By measuring, I mean put your hammer where you intend to hit. If I just took a wild swing, I may hit it here, but when I measure, I put my hammer where that hammer flow needs to go, and that way I get the control. This one, I'm going to use the fly press. Same thing, except that you got to have an expensive tool. And every tool in your shop needs to pay rent for being in your shop. So I'll demonstrate different uses for that fly press, and this is one of the things that I use it for. If you're in production, you want to make 6 pair at a time. It gets kind of dull at 10. 10's going to make, you're going to make some money at 10. But that way you can have everything set up, all these stations set up, and you could make a pair of tongs in an hour and a half, I think. Anything less than that, you're not going to get the details. So what I'm doing with this is basically just pressing that. And I'm going to press it just like I'm operating it, so that I get that full flattening effect on 90 degrees. This is number 8, and it's a deep throat, so it develops 8 tons of force. It's a Norton 8A. So here's what I did. I flattened that joint, and that one step right there makes a huge difference. When you're working with tongs that are sloppy, typically it's because that joint isn't nice and flat. So it's super important to all these little details. Radiusing that, reaming it, flattening that, and that'll give you a much nicer tool that'll last a lot longer. So, okay. So now I'm done with this. Done with that. Gotta make sure that before I get my rivet hot, so the next step is to be riveting. Get some wind kicking up. Get my rivet out. Let's see, where did that rivet hide itself? Maybe at the drill press. So we walked over here to the belt grinder, and what I want to do before I upset this rivet is I want to crown it just a little bit. Like that. When you crown a rivet, the force of the hammer blow goes straight into the center of that rivet. If you don't crown it, it may hit off center and it'll fall over. This way it'll give you a really even upset. So let's go back to the anvil. Now, when you rivet, you're going to want a head on one side and a head on the other. And that means that you need to do some calculations on how long that rivet needs to be. So that's 3/8, that's 3/8, that's 3/4. It looks like a 3/8 plus, actually. It's 7/8. So it's about 7/16, not 3/8. And that's fine, it's a sturdy joint. And when I use my rivets, I want at least the diameter of the stock on either side. So this has already been headed. So what I need then is the diameter of the stock on the other side. And I'm suggesting that that's at least. All right, so this is a 3/8 rivet, and I have 3/4 of an inch. And that's maximum. So the minimum you'd want on the other side is that much. The minimum, so that when I hit that, so 3/8 by 3/8, when I hit that, it's trapped by the hole, and that metal has nowhere to go except out. Maximum 3/4. Now you could say, well, I can upset more than 3/4. Yes, you can. One of the other journeyman tests in blacksmithing was to see if you could upset 1/4 inch round into the size of a manhole cover, but not everybody has that skill. So what I'm going to suggest is no more than 1.5 to 2 times the diameter of the rivet. And if you crown it, you'll get a much cleaner upset, and chances are that it'll be centered over the hole. So I'm going to heat the whole rivet, because if I only heat the end of the rivet, then it's going to be wobbly in there. You can see the slop that I have inside that. So if I heat the entire rivet, then the rivet will upset inside the hole and on the outside. You can heat the whole thing in your tong, but in other words, I could heat it with it out like that, and then I could heat that. But it'll take a little bit longer because the steel will conduct the heat away. So what I'm going to do is I'm going to heat it separately. And you could do this in your forge. or in this case, you could do it with the torch. Okay, it's always more interesting if you drop it a couple times. Don't put it on like that. Make sure there's no gap in here. Okay, so I've got no gap in here. I've got about the same amount of material on both sides. I actually like leaving that a hard edge. I could peen that down so that it was a rounded rivet, but that edge allows me to get things in the forge that are flat against the hearth and pull and drag it out. So now, if you've got a good rivet, that's a good connection. Even though it's only one, that's not going anywhere. So the next step on this is called ease the rivet. So I'm going to ease it with the heat. If I heat the rivet, it'll expand. Remember, the steel expands 1/8 of an inch per foot. So this is only 3/4 of an inch, but I'll get enough expansion on that to loosen up. Heating the head. Okay, so now I've got my tongs joined and I'm getting my 90 degrees, but they need to be adjusted. So I'm gonna put them in the forge to get an overall low heat. So we talked about this yesterday, where I use the forge instead of the torch often to give myself a preheat because it's very inexpensive. I'm not combining it with oxygen, it's not acetylene, it's just propane air. And I'll frequently preheat with the forge to get a very general heat, but not much more than slight incandescence. And then I will spot heat with the torch so that I have my intense heat where it needs to go. So I'm heating the area at the pivot, at the eye, at the pivot. Move this grinder over this glove. Use this vise. Now's not the time to let your guard down. Make sure that you're paying attention to your babysitting. You're not getting much more heat. And getting a little incandescence, and that's fine. what I want to do is I'm going to give myself an offset. So I'm going to heat right here and pull it out. Actually pushing away from the camera. Right there at the transition between the eye. I want to pull it out that much. Now thinking here, right at that transition of the eye to the reins, I'm going to heat it and I'm going to put pressure on it. If you don't put pressure on it, then the heat will climb. But if you put pressure on it, the heat will bend as soon as it's ready, as soon as it loosens its strength. Now, I'm going to skip back over here and about an inch up, and I'm going to put pressure on it, and I'm going to bend it back. I'm thinking here, right above, about an inch away from that first offset. And I've already got all that reserve heat in here, so it doesn't take very long. And I'm pulling it, and then the metal will tell me when it's ready to bend. Now I'll line them up, and that's how I get my offset. Now I'm going to drop it down in the vise, and I'm going to pull them so that they're all in the same plane. Drop it over here. And I'm going to pull it so that it's in the same plane. Now I'm going to take my twisting wrench and I'm going to make sure that the reins are nice and flat. Tighten this up a little bit more. So this has got a little twist to it. So it's coming up. That's good. Okay, now I'm going to go back to the forge and heat this area. And I want these to come together and I want these to come together. I'm going to squeeze the bits together and I'm going to squeeze the reins together. straight down. And I notice that these are kicking this way. So that means that this rein needs to come over. If it were kicking this way, then that rein would need to come over. So this will give me a center line between, I need 1 inch here of gap. And in between that center line, it's going to go from here, middle of the rivet, to the middle of that bit. Make sure that I get a little bit of gap in there so that when I hang it on my tong rack, they don't splay.